Now I am going to discuss few push-down automata problems and then followed by transition diagram of the push-down automata. So I have shared so many exercise problems. So in which one of the problem is design a PDA for the language L equal to A power n, B power m, C power n such that n greater than equal to 1 comma m greater than equal to 1. So what it means here, the number of A's are equal to number of C's, first condition, and the second condition is first A's then followed by B's then followed by C's. That is the second condition. And the third condition is there should be minimum 1A and minimum 1B, and so that minimum 1C. It means null is not allowed here. So as per the language constraint, the few accepted strings are ABC, WAB, CC, and ABBC, and so on. See, here the B should not be occurred without the occurrence of A, because number of A should be minimum 1, as well as C should not be occur without occurrence of B's, because number of B's also minimum 1. So obviously the first symbol should be A, that time the top is Z0, so it is stored into the PDA. So on Z0 A is stored, so Q0 A Z0, and this is for first A among the n number of A's, and later second A to n number of A's, this second function is required, Q0 A second A, the time top is first A. For example, it is fourth A, the time top is third A, like that. This is for enough to receive n number of A's. So coming bit is A, top is A, and even though it has to be stored because the future comparison of the number of C's. So this is enough for to receive all the A's. Means once A's are received, obviously the next occurrence of bit is B. Now coming bit is B, and that term obviously top should be A, and this A should not be ignored, because this A should be compared with the C's. Only simply ignore the occurrence of the coming bit B, but state need to be changed, because once B's occurred we should not receive the A's to store. So that's why the state Q0 to Q1 is changed. Now here the machine at Q1 state, in the sense A's are over and B's are started, n number of B's we can receive, even that time the top is A, and simply ignore the B, still the state is Q1. This is enough to receive any number of B's. It means B's are over, obviously next bit is C, that is observed by Q1 state, so Q1 C A, top is A. Now here comparison should be tallied, so for every occurrence of C, one A need to be removed. So Q now state change because the comparison started. Now comparison stated. Now for every C, every A ignored means coming bit is ignored and top is ignored, so null. Now Q2 on the roll, in the sense obviously coming bit should be C and corresponding PDA stop should be A, so both gets cancelled, so Q2 null, like this. Now whenever a coming bits are, this is enough to receive a number of C's as well as the corresponding in number of A's matching. So once C's are over, the coming input string is null and top is Z0, it means it is an accepted case, so this is equal to QF. And if you observe, now here the state at last is QF. This kind of automata is called as PDA is accepted by null store. But if you observe some problems here, here also the final state is QF, means this PDA also accepted by null store. And if you observe, for example, this 11th problem, now even number of zeros and even number of ones, here the final state is Q0. So here the PDA is accepted state. Okay, there are two kinds of PDAs, PDA by null store and PDA by empty state. Now this is for PDA by empty state. Now, so there are so many problems, solved examples for the PDAs, and then we are going to discuss one problem, which is fifth one, L equal to a power n b power m, such that not, I think not this one, we will see. Yes, fifth one. So we are going to discuss now. Here number of a's are more than the number of b's, and minimum 1a and minimum 1b, because n greater than 0, m greater than 0. For that we have developed some transition PDA with transition function. Now we are going to discuss the same PDA with the transition diagram. Here in the transition diagram already the vertices are states and a arrow represents the transition flow. So here if you observe transition functions, LHS is present state, present input and top of the PDS, and RHS is next state and how the PDS is modified. Now similar line, for example, if we consider the first transition function Q0 A Z 0, now it goes to where Q0 A Z, that means same state. Now here for example the function is written as, here written as, first of all Q0 is initial, so we should mention so the first function is can be written as Q0 and it goes to where, same state, self loop. What is the applied input? A, what is the corresponding top? Z0. But how top is modified? AZ0. This is for the first function equivalence diagram. Similarly, we need to complete all the functions in the terms of diagram. So consider the second function. Here the second function is Q0, coming input is A, top is A, and still it goes to Q0, means self loop. Now at Q0 self loop, here coming input is A, top is A, and how top is modified as double A. And come to the third example, third function, Q0 coming bit is B and top is A, and goes to Q1 and both are ignored. So Q0 goes to Q1 with applied input is what? B, and what is top? A, but both are gets ignored. This is about Q1. Come to the fourth function, Q1 B A goes to Q1 means self loop. Now here self loop, coming input is B, top is A, both are gets null. And come to the fifth function, Q1 null A goes to Q2 null, means it goes to Q2, which is a final state. So make us circle and mention the state name Q2, and here for Q1 applied input is null, top is A, and both gets ignored. So here what's the clarity? Coming input is over and still PDA is having A, in the sense number of A's are more than the number of B's. It gets final actually, but even though we need to test all the, we need to remove all the A's. So and Q, now what is the last but one function is Q naught null A is equal to Q2 null. Q2 null A is equal to Q2 null, means here at Q2 self loop coming bit is null, top A changed as, this is for to remove all the A's from the Q2, even still we are in the accepted mode. At last input is over, stack is over, in the sense we should observe coming input is null, top is Z0, and top is still mentioned as Z0. Now this is the equivalent transition diagram for the L language, L equal to A power N, B power M.